Okay, so this is period 1A. We are talking about lesson 5 on code.org, and we're going into variables today. Before we get there, though, we've started talking about the self-starter, and it's become quickly evident that we need a little bit more understanding of what the word parameter means. So last time in our lesson, we went over and talked about functions. Anyone remember what function means? What it is? What's a function? Hiram? Very good. A line. Hiram said a function is a line of code that does something in a program. However, a function is actually a series of lines of code. So we take several lines and we combine them together, and then when we call the function, it will execute all of the lines that are within that function. And so we talked about how sometimes functions need more information. So if we want to draw a square, what information might the function need? Cole? How big the square is going to be. We know that it's going to be the same dimension for the width and the height, but we need to be able to tell it how big that dimension is going to be. What else? What other information might the function need, Hiram? Okay, we've got the color of the square. What else? Brooklyn? Exactly. The program should be asking, or we should want to tell the program where we want the square to be drawn. Okay? Guess what we just named, guys? Parameters. Parameters are additional information that we give to a function so that it can perform those lines of code better. So we can tell it how big we want the square to be. We can tell it where we want the square to be. We can tell it what color we want it to be, if it has stroke or no stroke. All that information we pass to, or we give it to the function. And then the function uses that information to execute all of those commands that are inside of the function. Okay, is everyone getting a better understanding of what parameters are now? Think we can write a better definition for the self-starter, maybe? Okay. So we'll revisit your more intelligent answers in a little bit. What I'm going to do now, though, is I wanted to introduce lesson 5. So once again, those of you watching at home, we're moving at a pace of 1 lesson per class period. So last class period was parameters and shapes. So hopefully you figured out all of the little things with lesson 4. Today, we are jumping right into variables. Okay? So if I could have everyone close their Chromebooks for a couple minutes. Remember, well, did anyone actually get on code.org on their Chromebook? So they might change it during the period today. I sent the email to Mr. Butcher, but those of you watching at home, we are getting land school monitoring, and just basically because too many kids are screwing around during class, and so they're filtering all websites except the ones that have been approved. So I sent in code.org to be approved. We'll see if that works, but that's why we have the regular computers, because then we don't have to rely on the Chromebooks. Anyway, so here we are, lesson 5. We're going to look at this together. We're going to do like the first 3 or 4, and then you're going to be able to work on the rest on your own during the rest of the period. So, question of the day. How can we use before we get to this too, I wanted to really quickly show you guys this. So, on here, let's look at the progress of the class. Let's just see. Your class, actually, as I said, I'm not as afraid of, because you guys have the highest average and it looks like you are actually working and doing what you're supposed to. But let's check out how everyone's doing. And I'll show you what I can see as far as the dashboard goes and how I'm going to grade your stuff. okay? So this is going to list the progress of everyone in the class, okay? So we have your name, and then we have what you've done on the lessons. I don't care about lesson 1, so all of you guys with a blank, don't worry about it. It's okay. Lesson 2, I don't really care about that either because the grade for lesson 2 is going to be based on this worksheet that you hopefully find in right here. This is where it starts, the rubber starts hitting the road, lesson 3, okay? So you should have a completely green block for lesson 3. That means that you've gone through and completed all of the required challenges and things. So you can see we're about, like 50%, maybe like 45. We have a lot of people who are really close. So if I click on these, then what it's going to do is it's going to show me everything that you've done or haven't done. So you need to get to the check mark here. And then these here are those challenges. So once you get past 11, that's when you start getting the 3.2, 3.4, 3.6, 3.8, 4.0. So if you want to get the 4, you got to have some of these little dots on 11. But in order to get the actual 3, you need all of these checked off and the 10 checked off, okay? So I can see that, you know, several people have gotten to 8, they've done 10, but they kind of skipped the practice one. So they need to go back and actually get those done. And Dane's actually in a different class. I need to move him. But so there you go. So this is what I can see. And then each individual lesson, I can click on, see, here's what Garrett did. And I can go in, and this is what I will do, is I'm going to pick random lessons. I'm going to see, did they actually do what they're supposed to? Okay? So did he fix this to have the solution that he's supposed to have? Or is this the code, the default code that they had in the beginning, and they didn't do anything? Okay? So, I mean, you can see here, there's Garrett, and his is done. But if we click on someone who hasn't done it, let's do somebody who's not here. Oh, Henry's got 2 accounts. Here, Payson. Payson's new. Just started the class a couple weeks ago. Okay. So you can see this is the original. They haven't done anything. They haven't started the level. So if I click on it and yours is purple and it looks like this, then you're not going to get the points because I can tell that you haven't done anything. So make sure that you're actually completing the challenges before you push finish and move on to the next thing. So there you go. That's what I see on my end and how I'm going to grade things. I haven't been able to get to grading anything on code.org yet because I've been doing makeup work and lessons 1 and 2. But let's go ahead and look at lesson 5 here. Overview. I think this is me. Okay. How can we use variables to store information in our programs? This lesson introduces variables as a way to label a number in a program or save a randomly generated value. The class begins the lesson with a very basic description of the purpose of the variable and practices using the new blocks. Then completes a level progression that reinforces the model of a variable as a way to label or name a number. So a variable is a label for a piece of information that's used in the program. So you have to declare and assign a value to a variable, or you can just declare a variable. So those are the 2 different types of code that you can use. And then there's a little video, which we're going to see, I think, the next thing, the next screen. Hopefully you should be familiar with variables because we use them as we went to through the microbit programs. You remember we used the variable to keep track of the value of the dice. We used the variable to keep track of the score in Scorekeeper. We used a variable to keep track of how many people have entered Costco. Nearly all of our programs, if they were done the way they were supposed to, used a variable in there. So read the code below and make a prediction. Where will the circle be drawn? What will happen if you change the number in line 1? So everybody turn to your neighbor and discuss what you think is going to happen here. Where is the circle going to be drawn? And what happens if you change the code, which is right here in line 1? I'll pause this video. All right, we're coming back. Now we're going to share and talk about what is going to happen with this particular program. So, got a brave soul? Cole? Well, so what's the position? Well, both. Where is it going to draw? So you're saying it's going to be down here. Oh, down here. Okay. Hiram? Okay. You think it's going to be down here? Any other theories? What would happen if I changed this code here? How would it affect it, Brooklyn? Depending on how I change it, right? Okay, because I could make this 0 and it would go to the left. Okay, so what we're doing is we're taking, instead of putting an actual number here in the ellipse for the x position, we're putting a variable. And a variable, as it says, is just a label for a number. So the label here is x position and its value is 50. So the circle ellipse will be drawn in the lower left-hand corner of the canvas. Okay? So then when I run, it's going to be down here. Because, Cole, if you remember, x position is the first number and it's lowest on the left. And so if I'm at 50, I'm only going to be 50 away from the edge here. If I were at 350, so if I change this to be 350, then it would be in the lower right over here. Okay? All right, let's go back. Come on. 50. Okay. Okay, here we go. So here's our video. This guy's cool. I guess you guys need to hear this.
Most apps keep track of pieces of information that change and update as you use the app. For example, a simple game can keep track of your score and the number of lives you have left as you play. Apps utilize the computer's memory to do this, and learning how to use that memory in programming is a really powerful skill. The most common way to leverage a computer's memory is by creating a variable. Now, a variable is just a container for storing a value. And once created, the variable is stored in the computer's memory, and it can be used and updated repeatedly throughout the program. As an example, let's use variables to keep track of the score and the number of lives remaining in a hypothetical. Creating the variable is really easy. You use the word var followed by a label that you want to give to the variable. You can choose any label you want, but it helps to choose a word that describes the variable that you want to store. So let's label our first variable score to keep track of the score. And then we can create a second variable to keep track of lives. Remember these labels. You'll need them later in order to use the variables. We can assign a value to the variable using the equal sign, like this. Let's set our starting score to 0 and our number of lives to 3. Remember, you only need to use the var at the time that you want to create a new variable. A common mistake is to use it every single time you want to refer to a variable. Also, be sure to avoid mixing up the order when you call your variables. The label's got to appear on the left, and the value has to appear on the right. like this, not like this. Often, you'll want to create a variable and assign it a value right away. There's a really convenient way to do this with one line of code. This is sometimes called initializing the verb. It's important to realize that this single line of code is actually doing two things. First, creating a variable, and then second, assigning a value. Let's take a moment to talk about the equal sign. In many coding language, the equal symbol is called the assignment operator because you use it to assign a value to a variable. And you're probably used to seeing it in math, but in programming, it's a little bit different. If you were in math class and you saw this, something would definitely be wrong. Score can't possibly equal both 5 and 7, but this is not math class. With code, a computer is executing a set of instructions, one after the other. So this would just tell the computer to set score to 5, and then on the next line, set it to 7. In an effort to avoid confusion, programmers often don't use the word equals when we see by sign. Instead, they use the phrase gets the value. So when we see a statement like this, we could read it as score gets the value 7, or score gets 7. Some programming languages avoid the confusion entirely by representing the assignment statements with assignment arrows like this. To use a variable, you just refer to it by its label. Anywhere the variable name appears in the program, the value currently stored in the variable will be retrieved from memory. The tricky part is that when using a variable, you often can't see visually what its value is. To bypass that problem, you can use console.log to display the value like this. This is a really handy trick, but remember there's a difference between showing the value of a variable and writing out the variable's label. When text appears in quotes, you're telling the computer to write those literal ASCII characters on the screen like this. But on the other hand, without quotes, the computer assumes that you're referring to a variable called score, and it will attempt to retrieve its value. If you haven't made that variable, then the computer will get an error.
So, does that make any sense at all? Okay, and so here's the other thing. This is just the beginning. We're going to be doing a lot with variables. And so these simple things that he brought up and he talked about, if you're kind of just like, whoosh, like I have no idea what he just said, you're going to have a really, really tough time as we get into more complicated things with variables. Okay, so a few things that he brought up that I just want to reiterate. Number one, how can you use a variable? What's the first thing you have to do? Peter? You have to declare it, okay? What is the symbol to the computer that you are about to declare a variable? What are the 3 letters that you have to use? Yeah. VAR, var. That tells the computer whatever follows is the label for the variable that you are about to make. How many times do you need to use VAR when you make a variable? Show me how many fingers? 1, 2, 3, 4, how many? You only use it once, okay? So like he was showing, if you're making a variable called score, the only time you have VAR before the word score in your entire program is at the beginning when you declare that variable. Outside of that, you don't need the VAR anymore. You just use the word score and it knows, hey, this is a variable that he made or that she made and that they're using. Another thing that students commonly get mixed up in is the quotes. What was he talking about with the quotes? What are the quotes used for, James? Colin? Right. Okay. Quotes are for when you want to display what's called a string or a line of text. So if I'm going to show text on the screen and I put quotes around the text, it's going to show what's in the quotes. But if I want to show the value of the variable, then all I do is I put the name of the variable, which this is going to be really important as you start making a game, because you're going to want to put in this upper left-hand corner the word score so that the person playing knows what this is talking about. So you're going to have the word score, and then you're going to have the value of the variable score, right? Because it's going to say score, and then it's going to have a number. And as you get a higher score, that number is going to increase. Does the word score change? No, it just stays there. Okay, so you put the word score in quotes, and then you display the variable score. So it can get a little confusing. But I just wanted to point that out and hopefully have you get used to the idea of the difference between quotes and not quotes, because you're going to be using it later on. So let's look at this. In which corner of the screen will the circle be drawn? Okay, so you got X, position equals 300, and what's the Y is equal to 100. So what do we think? Give me a prediction. We have the ellipse, X position, and then what's the Y? So where on the screen is it going to be drawn? Oh, come on, same people. Let's get some new faces here. Henry, where's it going to be drawn? It's going to be in one of the corners. So it's either lower left, lower right, upper left, upper right. Upper right is what Henry says. What about other Henry? What does he say? Oh, wow. Bottom right. Okay. Brooklyn. Okay. So we got X position. If we look here on the grid, right? We move this around. So X position is going to be 300. So that means it's going to be this way, which is about here. And then the Y position, as Brooklyn was pointing out, is 100. So it's going to be the middle of the ellipse is going to be about there, right? So we could say that's mostly in the upper right-hand corner of the screen, okay? So it will be drawn in upper right corner. Run. Oh, there it is. Okay. Da-da-da. All right, we'll do this last one, and then I'll set you loose. You'll have like half an hour. All right, so name the variables. This program has multiple errors caused by bad variable labels. The errors prevent the program from being viewed in block mode, so the code is in text. Below are a few rules for naming variables. Click help and tips above to read more. Labels can't have spaces. Labels can't start with a number. Capitalization and spelling must be exactly the same. So find the rule each variable label violates. Correct the errors by picking new names that follow the rules above. If your program works, it should draw the image on the right. This. You should also be able to switch back to blocks mode. Okay, so they pointed out a really good thing here that help you realize if you're stuck on a puzzle and you're like, I have no clue what to do, before you give up, click on the help and tips, and it'll show you some stuff that will hopefully help you be able to figure it out. Okay, so let's see here. Labels can't have spaces. Labels can't start with a number. Capitalization and spelling must be exactly the same. So let's look at these. This label here, which rule does it violate? Eleanor? Okay, it can't have spaces. So when we do this, not only do we have to correct it here, but where else do we have to correct it? Brooklyn? No. This. Where else do I have to correct this? Henry? No. We've corrected it on line 1, but it appears somewhere else in the program, Naomi. Right. This is where we use the variable. So we're declaring it up top, but we also have to correct where it's being used. If you remember as well, when we did the microbits, they talked about making variables camel case. So you can tell it's a different word by capitalizing the first letter of each of the words. Now, if I fix it like this, is it going to work in the program? Why not, Eleanor? Right, we have to fix it down here as well. So it has to be exactly the same. So if we spell it wrong when we declare it, we have to spell it wrong when we use it. Or if we capitalize it a certain way when we declare it, we have to capitalize it that way when we use it. Okay, so what's the problem with this variable? Garrett. The one that's highlighted? What's wrong with that one? One dimension. Kind of like one direction, right? 1D. Oh, you're right. It shouldn't start with a number. So how should we fix this, Jack? We could spell out 1. What's another option that we could use, Kimball? Yeah, we could put it at the end. Okay, so we can either write out 1 dimension, or we can make it. That's not what there we go. Or we can make it dimension 1. Okay, so we'll do it that way. So we fix it here, and we fix it here. All right, so what's my final problem, Tommy? Right, so I need to do it the same way. So I'm just gonna make this lowercase, so y location, and all of my yellow triangles go away. I can now show my blocks and run my code. I'm a genius. Thank you. No applause, just throw money. I'll be here all day. Okay, so any questions on how we did that? You guys think you can figure this out? Yeah, I know. That's why I'm saying you guys are gonna be on the computers. You're not even gonna be on your Chromebooks. Close the Chromebooks, save them for the rest of the day, get on the computers. Those of you watching this later, thanks for joining us. Hope this was illuminating and you could figure this out. Yeah, good luck with lesson 5.